This is Chapter 8, 8.1, the Sine Law. Kevin?
The Sine Law. The Bermuda Triangle in the North Atlantic Ocean is the location of several unexplained plane and ship disappearances. Various theories have been suggested to explain this mysterious phenomenon, such as volatile weather patterns, magnetic compass variation, human error, and even alien abduction. Suppose you took a cruise around the Bermuda Triangle. How could you determine its perimeter from the given information?
Okay, so the question in the investigate then is, how are the side lengths and sines of angles related in an acute triangle? So it's very important when we start any of these questions that we understand the labeling process, or another way to think of it is they could say the nomenclature, okay? I can't stress this enough. It's such a small thing, but when people mess it up, it screws up the entire problem, okay? Opposite angle A. So angles are dictated by capital letters. So this would be here, this is angle A. That's what that little kind of wedge represents, the angle. Opposite the capital letter is the side length, little letter A, okay? So it's very important that you understand, if I say angle C, the side length opposite capital letter C is the lowercase letter c. So that represents the side length. So lowercase side length, capital case or capital letters, angles, okay? And their opposing or opposite side corresponds to the letter, okay? I'm taking my time with that and explaining it very deliberately because it's very important, because once we start to solve these problems, it's important that you know exactly when I say side little letter B, it refers to the side opposite the capital letter B angle. Okay? Any questions about that simple pattern? So here you see that there. So if I were to draw a triangle, any triangle, and then my vertices or my points, say H, I, J, you need to understand where is side J. So side J, where is it? It's right over here, okay, little j. Okay, little h should be over here, and little I is there. Okay, that's very important. If we don't understand that basic principle, you're going to get lost relatively quickly in these problems. Okay, the question says, how are the side lengths and sines of the angles related in an acute triangle? So draw an acute triangle, which we did, ABC. Measure the side lengths and the angles. So we can measure each one of these side lengths using a ruler. We can measure each one of these angles using a protractor. And then we can calculate the sine of each angle. So we measure this line here. Say we determine that this is 43 degrees. We can then calculate the sine value of 43. Okay? And what we find then is if we do these ratios of the side lengths over each other and the sine values of the corresponding angles over each other, we find out that they're all equal to the same value. Okay? So what we notice is we get this relationship where these ratios are equivalent. Okay? And this works for any angle and any side lengths, okay? As long as the triangle is drawn to scale and the angles and side lengths are measured accurately. Okay? So this here is the sine law. Okay? There's another way to write this sine law. Okay, so I'll put sine law 1. There's another way to write it. And it simply is the inverse. Or I should say the reciprocal. Okay, here's sine law number 2. These are identical equations, okay? The only difference is that I've rearranged them, right? If I were to take this equation, multiply by sine B, and then divide by B, I would end up by flipping the equation, okay? So, you have a choice then, whether to use this when solving the problems, or to use this when solving these problems. Anybody just off the top have an idea of when you might want to use this and when you might want to use this? Michael, yeah.
Sure, and the side length is bigger than the sine.
Okay. The side length is always going to be bigger than sine, because as we know, the sine of any value can't be greater than 1, right? The most we can get based on our unit circle is sine 90 is 1, right? Anything past 90 goes lower than 1. Anything before or past 270 is less than -1, right? So if we have any side lengths greater than 1, the side length's always going to be bigger than the sine value. Okay, so that's not the reason. Josh?
I think if the side length is unknown, you can use number 1 to make it over, and then if the angle is unknown, you can use the second.
Perfect. That's exactly the answer I was looking for, okay? That's exactly what you want to do. If your unknown is a side length, you're going to use this. If your unknown is an angle, you're going to use this. Why? Yeah, Steven.
When you're trying to find the side lengths,
Yeah.
when you make them equal each other, when you do like the scale thing,
Mhm.
you bring over the sine B.
Mm-hmm.
For example, sine B over to sine A, and then
Mhm.
the B is isolated, so that's
Mhm.
the top.
Okay.
And then the same thing for the other one.
Yeah, so the short answer is it's easier, right? It just makes your equation less work. Okay? Doesn't mean if you use this, you'd get the answer wrong. It just means that if you're solving for a side angle, this is going to be much quicker. Okay, you only have to make, as Steven said, one operation. Just multiply this side by sine B and you'll isolate for B. Okay, does that make sense? It'll make a little more sense as we go through some problems. Compare these results and explain what you notice. So what we notice is that they're equal. Repeat steps 1 to 3 for 2 different angles. Are the results the same? Believe me, you can take my word for it. Yes, they are. Okay, and if you're bored at home and you don't have enough homework, you can try that out for yourself. Okay, you can draw all sorts of triangles on some paper and measure them all and make sure that these are the same, but they should be. Okay. Number 5, it says summarize the relationships of the sides and the sines of angles in an acute triangle. So this is our summary, right? All right, Jason.
The relationship you investigated is called the sine law. To show why the sine law holds true, draw an acute triangle and add the altitude h from one of the vertices. The altitude splits triangle ABC into 2 smaller right triangles, triangle AXC and triangle BXC. Find an expression for h.
Okay, you can answer it for me. Go ahead, Jason. All right, so what we've done here is we put in this height here of any acute triangle.
No